I think now we can go to the reporting database tables load. We have seen most of the sections last week, the dimension table sections that we have seen after the database design, and I think fact table load that I asked you to go through in this week. So we'll start the possible interview questions on the fact table load. Some of them that we have seen on last week. Okay, all of the dimension table ones that we have seen in the last week. Okay, and some of you, I think most of you are closer to end of the course. That is really good thing. Definitely the people who are attending these lessons, so I think 70% of you closer to the finishing the course. That's a very good sign. That means you could able to follow through most of the bits and you are really doing good actually. Thanks guys. Okay, when coming to the fact table design specifically, if you look at the pipeline, it's all about identifying the associated dimension keys. That is the main thing in the fact table. And if you look at the data flow here, it's all joins between the our original source with the other dimension tables. Okay, so if they generally don't ask actually how do you load fact table, if the question will come across, you need to say that we will join the source business description columns or business keys. Okay, in our case all of the source data is existing as a description columns. Okay, for example, to identify the state id from the dim state table, we are joining the state name coming in the source file into the dimension table state name. It's normally it won't be the case. In the source itself there will be one id column will be coming, but it will be depending on the type of the source data we are getting. It's not necessary that id columns need to come from the source. If the id columns will come from the source, we always use the source id columns to match it. Okay, if the state id column will come from the source, till we generate the surrogate key. Surrogate key is specific to the our data analytical platform, dimension table and fact table joining keys. If there is a additional id existing in the state id to represent the state names, on top of that state id we will still generate the surrogate id. Surrogate id is the must to do in the dimensional modeling technique. Okay, so it can be a state name or it can be a state id, but all you are doing in your pipeline is you are reading your complete source data and you are matching your source state name with the source state name with the new surrogate IDs that you populated in the dimension table, and extracting the state ID in the same way market ID and the product ID and the date ID, everything you extracted and you load into the final target table. Again, the fact table is the one going to grow on daily basis. Okay, it will be get bigger and bigger. For even our example, I think we have got around 0.5 million records per year actually. If you load 3 years worth of the data here, we'll be having 1.5 million records. That is reasonably good size of the data that we are handling. That's why most of your Azure pricing is going up, I think, as soon as you use this one. Okay, so as we are loading huge data again and again, some of the queries related to performance tuning of the fact table load as well. Probably before going to the performance tuning, I will try to explore some of the additional options as well. Identifying incremental data for loading the fact table load. What does this mean is, from the landing layer, obviously every data coming into the landing layer on daily basis we need to insert into the fact table. There is no restriction that fact table only need to be loaded part of the data like dimension tables. Okay, all the data coming in the source we are loading into the fact table. So how will you identify only the new records coming in the source file? I think we are used to the same methodology for fact table and dimension table load. We using the get metadata activity in the Azure Data Factory, and this get metadata activity we have passed the start date time and end time, and between these straight range it will identify the list of files coming into this landing layer, and for each subsequent load we are passing the start time as end time as previous end time as start time and the new end time as a new end time. Okay, we are using the trigger mechanism to pass these values, and whoever done the exercise know that actually it incrementally pick up the only the new files coming from the source file, and we are passing that into the data flow to load the fact table in this pipeline. Okay, and hopefully that area is very clear. You can able to explain the same logic. Okay, there are a couple of mechanisms. We are using the Microsoft recommended mechanism. For example, if you look at the Microsoft Azure Data Factory documentation, they are asking to use tumbling window trigger, start time and end time to identify the new files coming into your landing area. The flow of reporting tables load, I specifically mentioned this one. This is related to along with the dimension table and fact table, which tables you load first and which tables you load next. So it's specifically talking about the sequence of loading of the dimension and fact tables. Just now we have seen that fact table need the dimension key surrogate keys, right? Without the dimension table surrogate keys, the fact tables cannot be loaded. So you need to load dimension tables first in your main pipeline. You need to include dimension tables load first and then load the fact table. In our case, the dimension tables are not changing. In the course, I mentioned that for running 365 days, I stopped to run the dimension tables load. I only started to ask you to run the fact table load because our dimension values are not changing on regular basis. Actually, there are distinct set of state name, distinct set of market name. Within loading 10 files, we got the full set of the dimension values. That's why I didn't ask you to load. But in the real time, you need to include both dimension table load pipeline and the fact table load pipeline into the same main pipeline to load end-to-end dimension tables and fact tables. Okay, there will be some questions related to handling missing dimension keys. Okay, for example, while loading the fact table, I am looking up the dimension keys from the dimension table. If the dimension key is not loaded in the dimension table, what would happen? Okay, for that record, will you insert into the fact table or you don't insert into the fact table or you skip those records actually? Again, in our case, for all of the keys are already available. This is literally extreme rare scenarios. Okay, for example, while loading the dimension table, the same source file is getting changed while loading the dimension table. Okay, in those cases, some of the dimensions may not be loaded into the dimension table while loading the fact table. So what we normally do is that if dimension key is missing, we populate with some standard value. It can be a -1 or even -99999, any of the values. Okay, this is the key values we populate into the fact table, and in the subsequent load, okay, subsequent load means next day or after a couple of days load, if dimension key available for this missing records, then we need to update the fact table. Okay, we need to update the fact table. This is going to be separate flow, we have not covered in the course. Okay, so what we need to do logically is that you come here, you loaded your first day, there are some dimension keys are missing, so you loaded with -0 and -999. So what you will do is that you will develop a brand new data flow. Okay, probably I can clone it quickly. Okay, here our source is going to be this fact table. Okay, not our mainstream source. Our fact is going to be our one of the source is going to be our fact table, and we join this fact table and this source table based on the keys you have derived. This is a little complex one. Okay, hopefully you will get it actually. Okay, I will read the data from sync table where any of my dimension keys are not -0, -1. Okay, either -1 or -999. I will read those records as one of the source here. Okay, along with all of this, I will include my sync fact table also. I'll share one of the source here. Okay, so for those records, I will try to identify them. For those records, first of all, okay, any of the key values are missing, I will join with the available dimension ID values by joining with main source. Again, I will create one temp table saying that this is the main source values for these missing values, and I use that source file as another source here to look up with the dimension table on the subsequent load to identify the missing values. There will be two flows involved. First of all, we loaded with -1 and -999 into fact table. You identify those records again one more time. Those records don't directly match with these dimension tables. Okay, some of the dimension tables the IDs are available, it will match with it, some of them it won't match it. That is the one approach. Or even the other approach is probably little thing you can, I think the first approach I am telling probably will be too complex. Okay, and before loading the sync table, okay, you can create a one filter transformation here. Probably this will be the very simple one. Here you are going to check your filter condition saying that any of your dimension key values are equivalent to -1 or -99. Okay, and you are going to store those records into the separate file, okay, with all of the source values, available source values along with that one. Okay, and you will develop the brand new pipeline and use this source file as a source again here, which includes the original source information. Again look up with the dimension table. If the subsequent load the dimension IDs are available, then you will reload that record into the fact table. Probably that approach will be little easier than the first approach that I am talking about it. There will be multiple approaches, but this approach probably you can able to easily relate it. Before loading the fact table, you are checking any of your dimension IDs are -1 or -999 and load that into the separate file. Okay, it can be in the landing file, a missing dimension key value, something like that, and you develop one brand new pipeline, use that as a source here and match with these dimension tables. Not on the same day, in the subsequent day it will get the proper dimension ID values and you can able to reload them into the fact table. So as long as you can able to explain saying that we will populate with -1 or -999 and in the subsequent LED the dimension values are available, then we will reload the fact table with the proper dimension keys. Probably that will give the answer for how to handling the missing dimension keys when loading the fact table. Now we are coming to the performance issues on loading fact table. Probably I will go back to this diagram here. Okay, if I need to identify arrival of the product apple in the specific state, for example Tamil Nadu, in the specific month, okay, you need to join this fact table with this dim state table to identify this state ID belongs to what state name, and you need to join this product to this product ID table to identify only the product apple, and then you need to do sum of the arrival in tons. That's how you generate the query. Okay, so what indirectly means is that these ID columns in the fact table always connected to the ID columns in the dimension table. So most of the time when we are selecting any data from this table, we end up joining with the dimension table using these ID columns. So what we do is we will create the database object called index. Index is basically probably I will take a specific state ID, select state underscore ID from dim underscore reporting underscore dim underscore state. Okay, so this information is stored under the database files. The actual data is stored it. That's how it's retrieving the data. The database software is doing it. So what it do is that for this state ID, it is stored internally inside the database and it will create the pointer to each of the state ID. Additionally, it will create the state ID 1 value is existing in this database file, or 1 to 10 is existing in this database file, and 15 to 20 is existing in this database file. This is all internally the database will create. All we need to do is that we need to create the index on the specific column or the specific table. Probably we go to design, is that to quickly allowing me to create the index. I will try to create the index. I don't think it's not clear. Okay. There is a syntax to create the index on the specific columns in the specific table. I think I will try to create it quickly here. If you say new index, it will ask the index name and what all are the column names that you need to create it. Okay, so index name I am giving it as idx underscore state underscore id, create index. You can have multiple columns as well on reporting dot fact underscore daily underscore pricing. Column name probably we can give it as state underscore id. So this is how you can create the index on the specific column in the specific table. It's taking little time because it's generating each unique state id value loaded into this fact table, and where it is located in this database server, inside the database server. What I'm talking about here is that each database has stored the data in the database specific files. As it's the serverless, probably it won't be displaying it here. It will, if you create the database locally, it will give the path of the database store. So it is creating index for each of these columns, whichever the columns that you are giving it here. You can have multiple indexes as well. One index for state id, one index for the market id as well. So it will speed up the query when you are joining the data between fact table and the dimension table. If the column specifically using in the join condition is used in the index, it will speed up the query because it knows physically where this physically where the values associated to this market id is stored inside the database server. It will quickly pick it up. This is good for retrieval, but when loading the data into the fact table, if the index is existing, when you add the new data, it need to update this pointer index as well. Okay, so that is the little time consuming process. So one of them, you can tell this in any interview. Fact table load, what is the performance issue that you have done? We can say that there are indexes on the id columns in the fact table, and we dropped that indexes before loading the data into the fact table, and we recreated the indexes at the end of the fact table load. That is the very standard way of improving the performance of the fact table load. There are indexes on them. Whenever I'm mentioning id or key column, it's all same. Okay, you know what I meant about it. There are indexes on the id columns in fact table. We have dropped indexes before loading into fact table and recreated them after loading fact table. Okay, that is one specific scenario with respect to fact table. I don't think much we can do on top of this one. By improving the performance of the loading, by the indexes, creating the indexes obviously improve the performances of retrieving the data from this table and also joining with other tables as well. Okay, and handling many to many relationships. Okay, as long as you properly design your star schema, the many to many relationship won't occur at all. Okay, it is impossible in the star schema many to many relationship will occur. It's always having one to many relationship. For example, there is a link between state name and market name. Okay, instead of creating two dimension tables, if you created one dimension table with state name and market name together, okay, and if you join just state id values with the state id here, the dimension table also will have, we try to simulate that one. Okay, I think it would be easier to simulate that one. Select distinct state id market name from fact table. Okay, one state ID is associated to multiple market names here. Okay, yeah. Now I'm just simulating how it will look like if we reporting dot dim underscore market. So this one is fact, this one is dim market, and another one is dim state, right? Dim state, dim state. Okay. Sorry. So dim market, I am saying that fact dot market underscore id equal to dim underscore market dot market underscore id, and probably one sec guys, I'm little quickly trying to do something. Inner join dim market on fact dot market id equal to dim market dot one. Again one more inner join with state on fact dot state underscore id equal to dim underscore state dot state underscore id. So now if we store state id, state name and market name together, dot state underscore name comma dim underscore market dot. I'm trying to simulate the single dimension table using joining between these tables. Okay, so if state name and market name, probably I will include them dim underscore market dot market underscore id comma dim underscore state dot state underscore id. Sorry, I think I'm doing too many spelling mistakes. If we stored our dim market name, okay, with state name as well, if we stored dim market name with state name as well, obviously the state name values get repeated here and state id values get repeated here. Okay, order by dim state dot state id will give you the clear distinction. Okay, so state id is repeated here. That means state id appearing in more than one time in the dimension table. If I join the state id with my fact table state id, obviously fact table the state id is again appearing multiple times. That means it is establishing many to many relationship between dim market with the fact table. That shouldn't be allowed actually. That is the main reason we are kept on saying that each dimension table need to store only one-to-one relationship related to the columns. If you join with many to many times, for instance, if I need to calculate the sum of arrival of quantity for a 1 month, what need to happen is that the dimension table month id one time need to join with many records in the fact table. But what here it would happen is that many times of the state id will join to the many records of the table. For example, specific state id 1, if there are only 10 records are existing in the fact table, the total number of records need to come as 10. In this case, what would happen is that there are 26 states are there. So 26 times of 10 it will generate it if it has got the many to many relationship. This is the wrong calculations. We do not have this many records for that state in the fact table, because of we are storing many to many relationship attributes together in one dimension table, and these values are joined to the fact table. Each of the state IDs, even though these 10 records are related to only one state, each of the state ID values will be joined that many times and it will produce the 260 records. That shouldn't be allowed. But if you properly design your dimensional modeling, it won't happen. Okay, you can guarantee that one. That is the one of the advantage of the dimensional modeling. But for some reason, if you need to combine them together because of the business requirement, you don't directly join. For example, I will extend this one with the additional columns that we discussed now. If for some reason you created that one and it's happening in your model, you can't able to avoid it. What you need to do is that you need to create the additional bridge table. We call it as bridge table. Okay, which will include I'm going to say dim market underscore state underscore bridge. Here you will have distinct state IDs and distinct market IDs, and the joining between this table and the fact table is not based on one of the column. It always based on the state ID equal to state ID and market ID equal to market ID, so that the multiple state values won't be mixed up together. Combination of these two, state ID and market ID, if you look at it, it is always the 1 to 1. Even here, if you look at the state name, state ID and market ID together, it is not duplicated, but state ID alone is duplicated here. Okay, so it always need to join with two ID columns together into the fact table, then it won't create the unnecessary duplication of the data or miscalculations. So whenever any questions will be coming on how to handling many relationships, you need to create the bridge table to have one to many relationship to establish, probably to establish the one to many relationship between dimension table and fact table. Okay, the data modeling, I think I'm going too in depth. Okay, I'm trying to see all the possibilities of the questions here. Again, if some of them you can't able to map it, please send me a message. Okay, I'll try to explain it. But we are not expecting these questions come to us because this is all data modeler questions. But any of the context that you can able to answer it, that will give you them so much boost on your profile. That is my main aim. Again, handling error records when loading the fact tables. Even we have got some error records, it got loaded into the fact table. I can quickly show to you. Where is it? Yes, from select star from if you look at some of the pricing values, the values are null because we have defined minimum price and maximum price and model price as decimal values. Some of the source values coming as a varchar values. So we won't be able to load the string values into the decimal values. It's stored as null. Instead of loading the null, we can able to redirect this error records into the separate file so that we can clearly distinguish what happened while loading the fact table. So if you come to the fact table loading pipeline, if you come to the sync, there is a specific section called errors. Okay, here you can choose to redirect your erroneous records into one of the link service. It don't need to be data lake storage. It can be a SQL Server database as well. So you can choose this landing link service here. You can choose whether stop on first error or continue on the error, and you can output your file into the separate file. So it will, if you go to the browsing, it's going to the landing layer containers. Even you create the separate container for erroneous record and you give the file name, it will load all of the records, erroneous records that it won't be loaded into the final table. It will load it here. This is not our problem, this is the source data problem. So that is the best option. We have done it in the course as well, not in this section, but in the later part of the course we definitely when loading the gold price prediction data, I think I have redirected into the erroneous record. where is the gold price prediction data? Yes, I think in this pipeline, this can be done in the copy data activity as well. Okay. The erroneous data we are redirecting into the separate file here, and it will load that erroneous data into the separate file. So that is the one of the option to handling the erroneous record. That is the best option because this is nothing to with our code. This is the source data issue. We redirect the erroneous records into the error container in the Azure Data Lake storage, and these records can need to be informed to the source Possibly source can fix it in the future and resend the proper data. So that's all I would like to discuss in the fact table load.